Breaking news, and this is big. Ukraine just secured the ultimate shield.
This is huge.
As of today, January 25, 2026, it is confirmed. Ukraine is getting 8 next-generation RMANTD systems to wipe out Putin's troops.
And we are looking at a fundamental shift in the air war. This isn't just an upgrade.
No, not at all. We are talking about a literal world-first deployment of tech that didn't even exist operationally a year ago. It's the kind of hardware that just changes the entire math of the war.
It really is.
But before we get into the nuts and bolts of how this breaks the Russian air offensive, if you want to stay ahead of the curve, you know what to do.
Yep.
Make sure you subscribe to Defense Reports. We are your go-to source for timely, in-depth military and defense reports.
Absolutely. You really don't want to miss what's coming in 2026.
I'm Alex. Join me with Arya in the latest deep dive by Defense Report for a sharp, no-nonsense breakdown of the latest in global defense news, military technology, and strategic developments. And today, we are covering the delivery of the French-Italian SAMP NG.
That's new generation.
And why it is, frankly, terrifying news for the Kremlin.
And we have to start with the why. You know, why was Ukraine so desperate for this specific system? It wasn't just about getting more air defense.
Right.
It was about a secret crisis that hit late last year in 2025. A crisis where interception rates against Russian missiles didn't just dip, they plummeted.
To levels that must have kept generals awake at night. We're talking numbers so low they were classified immediately.
Yeah.
Single digits.
Exactly. The old shields were cracking. And the solution isn't just a bigger missile, it's a system that moves differently.
Right.
The AMPT-NG uses something called PIF-PAF technology. It uses lateral thrusters that, it makes the interceptor move like a UFO.
To hit hypersonic targets that are actively trying to dodge it.
It's missile kung fu, basically.
I like that. But the implication here is huge. This isn't just about playing defense. This is about neutralizing the Russian aerospace forces to, clear the way for Ukraine's ground operations later this year.
100%.
So let's unpack this. We have to rewind to late 2025. What exactly went wrong?
Okay, so to understand the solution, you have to understand the failure. For a long, long time, the US-made Patriot PC-3 was the gold standard.
It was the icon of air defense.
It was. But in September 2025, the data changed drastically.
I remember rumors started flying in August, but I have the confirmed numbers here. In August 2025, the interception rate against Russian Iskander-M and Kinzhal missiles was around 37%.
Which isn't great, but it's workable.
It's manageable. But then in September, it dropped to 6%.
6%. Just let that sink in for a moment.
So for every 100 missiles Russia launched,
94 we're getting through. That is a catastrophic failure. The shield didn't just crack, it shattered.
What happened? Did the operators suddenly lose their touch?
No, not at all. The Ukrainian crews were operating perfectly. The problem was that Russia adapted. They realized they couldn't beat the Patriot with speed alone, so they changed the software and the flight profiles. Their missiles started using these really aggressive terminal phase maneuvers.
Right, so instead of coming in on a predictable arc like a thrown rock, they started swerving violently right before impact.
Violently. And they combined that with advanced radar decoys. But here is the fatal flaw they exploited. The legacy Patriot radar, the ANMPQ-65, it has a sector view.
So it only sees about 120 degrees in front of it.
Exactly.
Let's visualize that. It's like looking through a paper towel tube. You can see everything inside that tube perfectly, right? But if someone sneaks up on you, or even just slightly to your left,
you're blind. Completely blind. The radar mechanically rotates, but it's slow. If a missile is coming in at Mach 5 and pulls a hard turn outside that 120-degree cone,
the Patriot just loses it.
It loses the track. It can't shoot what it can't see. This is what allowed Russia to hammer critical infrastructure and drone production facilities late last year.
So Ukraine needed a system that doesn't blink and sees everywhere at once.
Which brings us to the Mamba, or rather the Super Mamba, the NMPT-NG.
This deal was signed back in November 2025 by President Zelensky and Macron, a massive 10-year security pact.
But the headline is the delivery of 8 full systems.
8 systems. That's what, 48 launchers in total?
48 launchers, but what really stands out is the timeline. We're seeing the manufacturers, Thales and MBDA, confirming commissioning right now.
Which is crazy. Usually Ukraine gets the hand-me-downs, the stuff sitting in a desert storage yard for years.
Not this time. Ukraine is receiving these systems effectively alongside, or maybe even slightly before, the French and Italian armies fully field them.
Wow.
It's the global debut of the NG variant in a hot war. It's a massive vote of confidence and honestly a massive risk for the manufacturers if it doesn't perform.
It's a trial by fire, so it's built by Eurosam, a joint venture between MBDA and Thales. They call it Mamba. But you're saying this NG version is a quantum leap.
It is. It was designed specifically to hunt the very things that were killing the Patriot. Hypersonic ballistic missiles that maneuver. It fixes the two biggest problems: detection and agility.
All right, let's get into the tech deep dive. This is where it gets really fun. We have the eye and the claw. Let's start with the eye, the radar.
This is the heart of the upgrade. So depending on if it's a French or Italian unit, it uses either the Thales Groundfire 300 or the Leonardo Kronos GMHP. But the tech underneath is similar. It uses gallium nitride, GaN technology.
I see GaN on high-end phone chargers now. But why does that matter for a military radar? Is it just about efficiency?
It's about power density and heat. Old radars used gallium arsenide. If you pumped too much electricity through them to try and see further, they would literally melt. GaN can handle much, much higher voltages and temperatures.
So you can crank the volume up to 11 without blowing the speakers.
Precisely. You can pump a massive amount of energy into the sky. And unlike the Patriot's 120-degree window, these radars use an active electronic scanning array that spins. It gives you 360-degree continuous coverage.
So going back to our analogy, no more paper towel tube.
No tube! It's like standing in an open field with eyes in the back of your head. You cannot flank this radar.
And the range is insane, up to 400 kilometers.
But the real kicker is the processing. The legacy radars could track maybe 130 targets. The Groundfire 300 can track over 1,000 targets simultaneously.
1,000? That seems like overkill unless you're fighting, well, the entire world at once.
Or unless you're fighting a saturation attack. Think about a typical Russian strike. 12 cruise missiles, 5 ballistic missiles, and 50 cheap Shahed drones all coming at once to confuse you.
The old radars would get overwhelmed.
The computer literally couldn't process the tracks fast enough. This system sees everything, from the low-flying drone skimming the treetops to the ballistic missile on the edge of space, classifies them, and prioritizes the threats instantly.
That is the eye. Now give me the claw, the missile, the Aster 30 Block 1NT.
The NT stands for New Technology, simple name, very complex engineering.
The magic here is in the seeker, right? The little radar in the nose of the missile. I read that most missiles, like the Patriot PET-T3, use a Ku-band seeker.
They do.
But the Aster 30NT uses a Ka-band. That sounds like a minor detail.
It sounds minor, but it's a huge difference in physics. It's about wavelength. Ka-band is a much higher frequency. Think of it like the difference between an old standard def TV and a modern 4K screen.
Resolution.
Exactly. When a Ku-band missile gets close, it sees a blob. If Russia deploys decoys, the missile might go for the brightest blob, which isn't the warhead. The Ka-band seeker sees with enough resolution to distinguish the actual shit.
So it can tell the difference between the warhead and the decoys.
It ignores the chaff and hits the bomb. Precisely.
Okay, and that brings us to the Kung Fu move you mentioned, the PIF-PAF system.
Yes, pilotage on force.
But wait, pretty much every missile steers. Why is this different? Usually you just have fins on the back that wiggle, right?
Right, and that works fine in the lower atmosphere where the air is thick. The fins have something to push against. But the Aster is designed to intercept ballistic missiles way up in the stratosphere,
where the air is incredibly thin.
So fins don't have anything to push against. It's like trying to steer a boat with no water.
Exactly. If a Kinzhal jukes at 20 kilometers altitude, an interceptor with just fins will turn too slowly. It'll miss. The Aster solves this by placing lateral thrusters right at the missile's center of gravity.
So it has little rocket boosters on its side.
That's a good way to think of it, yes.
Yeah.
It creates a direct vector of force, allowing the missile to pull 60 G maneuvers.
60 Gs! That is violent. A human pilot passes out at 9. If you put a human in a 60 G turn, they'd turn into jelly.
They would be liquid. 60 Gs means the missile doesn't have to bank in a wide arc. It can literally slide sideways instantly. So when that Russian Kinzhal does its terminal dodge,
the Aster just slides right into its path.
It's a hit-to-kill system. It slams into the target physically. A bullet hitting a bullet that's actively trying to dodge.
A bullet hitting a hypersonic bullet. And it can do this at ranges beyond 150 kilometers and up to 25 kilometers in altitude.
That brings us to tactical dominance. Because it's not just about the missile, it's how you use it. We know that in Ukraine, static defenses are dead defenses.
Shoot and scoot. This is where the SMPT-NG design philosophy is radically different from the Patriot. A Patriot battery is a heavy, complex beast designed to sit behind the lines in Germany. It takes 30 to 45 minutes to set up or pack up.
In a world of hypersonic missiles and loitering drones, 45 minutes is an eternity.
It's a death sentence. If you fire, the Russians triangulate your position. If it takes you 45 minutes to fold up your radar, an Iskander or a swarm of Lancets will be there before you leave.
And the SMPT-NG.
15 minutes.
That's incredibly fast. You can barely make a coffee in that time.
It changes the risk profile entirely. You roll in, deploy, fire, and you're gone moving down the highway before the Russian counter-battery fire can even arrive. It allows Ukraine to be aggressive.
Plus, the manpower difference is stark. A Patriot battery needs about 90 highly trained specialists.
Right, and the SMPT-NG needs only 14 to 20. That's a huge deal for Ukraine. It's easier to hide 20 guys than 90. It relieves pressure on their mobilization.
Okay, we have to talk about the war of accountants. Because wars are expensive, and shooting down cheap drones with multi-million-dollar missiles is a great way to go broke.
This is the economic asymmetry problem. A Patriot PAC-3 MSE interceptor, the top tier one, costs anywhere from $4 to $7 million per shot.
That is painful, especially if you fire two just to be safe.
Exactly. You could spend $14 million to shoot down a missile that costs Russia maybe $2 million. That is a losing equation. The Aster 30 B1NT, it costs roughly $2 to $3 million.
It's about half the price. Still not cheap, let's be real. But in the context of state-level warfare, that difference is massive.
It makes the defense sustainable. If you're fighting a long war of attrition, which this is, that math matters. You can stockpile twice as many missiles for the same budget.
And there's the political side of the supply chain. We've all seen the frustration when aid gets stuck in the U.S. Congress.
This is where being ITAR-free becomes critical. ITAR is the U.S. regulation controlling defense tech. If even one U.S.-made microchip is in a missile, Washington has a say.
And that can paralyze the supply line.
Exactly. The MET is European, built by MBDA and Thales. Ukraine deals with Paris and Rome. They don't need to wait for a vote in Washington.
That's European strategic autonomy in action. And I hear MBDA has ramped up production significantly.
500% over the last 2 years. They are pumping out Aster missiles because they know this is a war of volume.
So we have a better radar, a more agile missile, it's cheaper, and it's easier to move. How does this fit into the bigger picture for 2026?
Well, this system integrates perfectly with the new offensive assets Ukraine is getting. Remember, 2026 is the year the Swedish Gripen jets and the Saab 340 AEWNC radar planes come online.
The flying radars, we talked about those.
Right. The SAMP-TNG speaks Link 16, the NATO data link. So imagine this. A Saab 340 is flying safely in western Ukraine. It looks deep into Russian-occupied territory and sees a Russian jet flying low. The SAMP-T on the ground can't see it because of the Earth's curvature.
But the plane sees it.
The plane sees it, beams the target data to the SAMP-T, and the battery fires. The Aster missile launches before its own ground radar even has a lock. It flies to the coordinates, then its own Ka-band seeker turns on for the kill.
That's over-the-horizon engagement. And you've called this offensive defense. How does a shield become a sword?
By pushing it forward. With a system you can pack up in 15 minutes, you can bring it dangerously close to the front line.
Ambush tactics.
Exactly. Russia is using glide bombs, cabs dropped from bombers 60 kilometers behind the front. It's been devastating. But if there's a SAMP-TNG lurking near the front, those bombers are suddenly inside the kill zone.
So they have to back off.
And if they back off, the glide bombs can't reach the trenches. You deny them the airspace. That allows your own ground troops to operate without getting hammered from the sky. That is how an air defense system breaks an offensive.
And it effectively neutralizes the hypersonic coercion.
It does. Putin loves to threaten decapitation strikes on Kyiv with Kinzhals, claiming they're unstoppable. The Aster 30 B1NT is proven to stop them. If you can't threaten the capital with impunity, you lose a major lever of terror.
It really feels like the arrival of these aid systems is a turning point. We've gone from scrambling for spare parts to fielding the most advanced tech on the planet.
It's a maturity of the support. It's no longer about giving Ukraine what we have lying around. It's about giving them the specific tools to win the technological war.
So let's recap this game changer. A 360-degree radar that sees everything, no blind spots, a missile that moves like a UFO and costs half as much as the American equivalent, and a system that moves fast enough to survive the modern battlefield.
And crucially, a supply chain that is firmly in European hands, immune to political gridlock across the Atlantic.
Which brings us to a final thought. We spent decades assuming American hardware like the Patriot, is the only game in town for high-end defense. But here we have Europe stepping up with a system that, by many metrics, is actually better suited for this specific fight.
It raises a fascinating question. With the U.S. focus split between multiple global theaters and with the political complexities in Washington, does the deployment of the AMP-TNG mark the moment Europe finally took charge of its own continental security architecture?
Is this the beginning of a true European shield? That is something to think about as we watch these systems roll out. You've been listening to Defense Report by Alex and Arya, where we analyze the latest in military strategy, global defense, and advanced weaponry.
And we'll be watching the skies over Ukraine very closely in the coming weeks to see the Mamba in action.
Absolutely. If you enjoyed this deep dive, don't forget, subscribe to Defense Reports, your go-to source for timely, in-depth military and defense reports. We'll catch you next time.